Field effect transistors. This is the structure of a particular field effect transistor. Similar to BJT, we are going to use this field effect transistor in various electronic application, right? The role of a particular transistor is, to control the current that is flowing through this particular device, right? Similar to this tap, right? A tap which is going to have a source of water and a wall which will be used to control that particular water flowing through this tap, right? And the amount of water uh, that the wall is going to control, that is going to drain at this point. Okay, so similar functionality is of particular transistor is there, right? We have a gate terminal, right, which is going to control the current flowing through this device, right? Let us see in more detail the construction working of this field effect transistor. Application of field effect transistor are amplifier, analog switch. It can be used as current limiter, multiplexer, oscillator, and many more. When it comes to the similarity between the BJT and FET, it is having three terminals, right? Okay. BJT, we have a base current for controlling the collector current, right? In FET, we have the gate terminal that is used to control the current flowing through this device, right? Differences between FET and BJT. FET is voltage control device, while BJT is current control device, right? FET offers higher input impedance as compared to this BJT. FET is unipolar device as it uh, delivers the current, or the current whatever is flowing through this device is because of mostly the only majority charge carriers. So the current is flowing because of the majority charge carriers. So it is the unipolar device, right? In case of BJT, both the minority and majority carriers are responsible for the current flowing through the device. So that BJT is called the bipolar device, right? FET can be integrated in very small size as compared to BJT. So we can integrate very large circuits within integrated circuits, okay, as compared to the BJT, where BJT will be responsible for having bigger size of integrated circuit. Types of FET. Basically, we have different types of FET, right? Broader classification is JFET, junction field effect transistor, and MOSFET, metal oxide semiconductor field effect transistor. Let us focus on JFET. JFET is also having two types. One is N channel FET and P channel JFET. It is going to have three terminals: drain, source, and gate. Okay. On left hand side, this is the N channel JFET. It is constructed by using a N semiconductor, N type semiconductor. So we have N type semiconductor, and within this N type semiconductor, we have implemented P type semiconductors here and here. And yeah, we have connected both these P materials, P regions with each other with this metal. We call this terminal as gate. Okay. So what we have within this drain and source terminals, these are the metals, we get a complete N type of semiconductor. And this N type of semiconductor, uh, it is going to be carrying current through it, and that current which is going to be controlled with the help of the P type of gate. Okay, so we say that the current is flowing from this drain to source, right, within this N semiconductor, right? So we call this device as N channel FET, right? There is a channel form through which current is going to flow, and this channel is made of what? N type semiconductor. So this is the N channel JFET. Similarly, we have the P channel JFET. So we will be having a P-type semiconductor, and within this P-type semiconductor, we will implement N-type semiconductors here, right here. right? So what we will get, we will put a drain terminal here and we will put a source terminal here, right? So between drain and source terminal we have a p-type semiconductor. So current is going to flow through this p-type semiconductor. We call this as p-type channel, right? And this current is going to be controlled, yeah, by this n semiconductor regions, right? Semiconductor regions, n type material, which are connected to each other with the help of a metal. We call this as gate. So it has three terminal: drain, gate, source, right? Current is going to flow through this p type semiconductor, which we are going to control with the help of this gate. So this device is called p channel JFET. Symbols, right? The arrow is indicating the flow of current. So in N channel FET, we have this drain enter source terminal, right? Connected to here. And this gate terminal is going to control the current flowing through this drain to source. But in case of N channel, this arrow is going to indicate the flow of current, right? So whenever this arrow is inward to this device, then it is an N channel. In case of P channel, the arrow will be outward of this device in the gate. Okay, so this is a P channel.